Good afternoon, students, and welcome to our third quarter, week 5, part 2 discussion. This is Aljibuyan, your ICT subject teacher. So, for the part 2 of your this week's activity or discussion, we will be talking about basic concepts of electricity. So, but before that, let me introduce to you our objectives for this part 2 discussion. So, at the end of the lesson, the students will be able to A. Recognize the basic concepts of electricity. B. Differentiate direct current from alternating current. And C. Appreciate the importance of basic concepts of electricity. Okay, so let's begin our discussion. So, basic concepts of electricity. So, what is electricity? So, electricity is defined as the flow of electron or electric current. So, it is an invisible form of energy that can be transformed into other form of energy like heat, light, and mechanical. So, these are the basic electrical terms. So, we have first electron, which is the negatively charged component of an atom, and it has the ability to flow. Then another, we have proton. So it is the positively charged component of an atom, and it had the ability to attract electron. So these electron and proton, they have a bond with each other. Then another, we have matter. So matter is anything that occupies space and has mass. Can be a solid, liquid, or a gas in state. Okay, we have atom. So atom is basic component of a matter. So it composes of a nucleus, which is the central part, and the protons and the electrons. So that is the atom. Then we have another, current. So same as electricity or flow of electron. So the current is just like the electricity or the flow of electron, and it has the amount of current flowing in a circuit, which can be measured in an ampere, or the symbol of that is letter I. Then we have another, voltage. So the amount of pulling force that makes the electron flow, so that is the voltage. It is also known as potential difference, or EMF, or electromotive force. So the amount of voltage can be measured in volt, or letter V for these for the symbol. Then we have lastly the resistance, which defines as the opposition to the flow of current. So the amount of resistance can be measured in ohms, or the omega sign. Okay, next. Conductors and insulators. So conductors are materials that easily allow the flow of current, or it has a low resistance to current flow. For example, aluminum, gold, silver, copper, and iron. So these are examples of conductors to electricity. Then we have insulators. These are materials that do not easily allow the flow of current, or it has a high resistance to current flow. And the examples of these are rubber, plastic, and paper. So the difference between conductors and insulators, when we touch aluminum and we made it contact to an electricity, or a thing that conducts a thing that has an electricity, then we will be electrocuted if we hold aluminum, gold, silver, copper, and iron with the electricity. Then for the insulators, if we hold it, for example, the rubber or the plastic or the paper, we will not be electrocuted even if our rubber, the plastic or paper, will have contact with electricity. So That is the difference between conductors and insulators. So types of current. So we have two types of current. So these are direct current and indirect current. Indirect current, or DC, the flow of electric charge is only in one direction. So this is the type of electricity which is produced by batteries, static, and lightning. So a voltage is created and may be stored until it is consumed. So when the current flows directly in one direction in the circuit, the current flows at a specific constant voltage. So this is oversimplified somewhat, but good enough for our needs. So when you use a flashlight, pocket radio, portable CD player, or virtually any other type of portable or battery powered device, you are using a direct current. So most DC circuits are relatively low in voltage. Just like, for example, your car's battery is approximately 12 volts, and that's about a high voltage as most people ever use. Then for the alternating current, so in alternating current, the movement of electricity or electric charge periodically reverses direction. So this type of electricity is produced or generated by AC generators, commonly from a hydroelectric plant. So it is the commercial power that we use in homes and offices, so delivered through a power transmission lines. So AC current or alternating current can be reduced through the use of power transformer to suit for its application. So it can also be converted to DC for a specific purpose. So in the Philippines, AC or alternating current is rated as 220 volts AC at 60 hertz. So that is alternating. Then alternating currents change direction. So flowing first one way and then the other. Just like in the picture or the illustration below. So they are sinusoidal waves so that they change in time. They are produced from sources such as power supplies and AC generators. So in North America, alternating current is 120 volts and 60 hertz. So it's bigger than the Philippines, or here in the Philippines. So 60 hertz or cycles per second. So this means it changes direction 60 times per second. In Europe, it is generally 50 hertz with 220 to 240 volts. That's an example of alternating currents. Then I have a question. So this question goes, why does standard electricity come only in the form of alternating current? So this could be the answer, or this is the answer. So there are a number of reasons, but one of the most important is that a characteristic of AC is that it is relatively easy to change voltages from one level to another using a transformer. So while transformers do not work for DC. So this capability allows the companies that generate and distribute electricity to do it in a more efficient manner. So by transmitting it at high voltage for long lengths, and which reduces energy loss due to the resistance in the transmission wires. So another reason is that it may be easier to mechanically generate alternating current electricity than direct current. So PC use only direct current, so which means that the alternating current provided by your utility must be converted to direct current before use. So this is the primary function of your power supply. So the illustration below allows us to see the simplified block diagram of a PC power supply. So we have AC power, then the personal computer's power supply, then go to DC power, then the DC power goes to the motherboard, the drives, and the cooling fan. So the DC power will distribute its electricity to the motherboard, the drives, and the cooling fan. So that's how it goes, the alternating current for the personal computers. Okay, now let's move on to electric current, or electric circuit. So electric circuit is the pathways of electricity to flow. So components of circuit are load, supply, and switch. So first, load, which is commonly represented by a bulb or any electrical component that consumes electricity. So these are any electrical component or bulb which consumes or gumagamit ng electricity or kuryente. Then we have next supply. So this commonly represented by a cell or a battery. A cell or a battery. So for supply, they can be seen as or represented as cell or the battery. And for switch, which is an electrical device that opens or closes a circuit. So this is what we click or turn on or turn off when we let our lights light our so this is the use of our switch. Then next, okay, so we have the types of circuit. So the two types of circuit are open circuit and closed circuit. So let us discuss first the open circuit. So an open circuit is a type of circuit that has an open path or for current to flow. So it means that current cannot flow in open circuit. So just like the illustration below, so the figure 5, so it is an open circuit. So the switch is said to be open. The current can flow into the current or the circuit, and the bulb is off. So that is an open circuit. Then for closed circuit, so this is a type of circuit that has a closed path for current to flow. So it means that current can flow in a closed circuit. So the switch is said to be closed, the current can flow into the circuit, and the bulb is on. So when we execute the closed circuit, so which it means that our bulb or our what we call the the thing that consumes electricity will parang umaandar or it will give light. So when it is closed circuit, parang yung light natin is naka-on. And then for open circuit, yung light natin is naka or walang ilaw or naka-off siya. So that is open circuit, and then the closed circuit current. Okay, so that's all for this week's discussion. Thank you, and may God bless you. And if ever you have any questions regarding the topic, you can message me in Messenger, or you can also call me. You have my contact number on your module, and if ever you want to see this video again, you may access this on our LCMS platform. So it's the lcms.gaitf.com. Thank you again, and may God bless you.